On today's battlefield, victory can be decided in a fraction of a second. So today, we're going to dive into a huge shift in ground combat. And it's not about bigger weapons or stronger armor, it's about something you can't even see: the algorithmic sentry. We're going to explore how artificial intelligence is giving soldiers a totally new kind of sight, a new speed of thought, and really, a whole new way to fight. For the last 70 years or so, figuring out who's a friend and who's a foe has been a pretty simple reactive process. It's kind of like a password check, right? A system sends out a challenge, and a friendly tank or plane replies with the correct response. Simple. But AI, well, AI just changes the whole game. We're moving from that old school challenge response model to something called predictive awareness. So instead of just asking, hey, are you a friend? These new AI systems are constantly watching, they're learning, and they're understanding the entire battlefield to predict threats before they can even make a move. Okay, so what does this actually look like on the ground? Well, it all boils down to one critical thing: speed. AI is basically injecting machine-fast processing right into the heart of tactical decision-making. And believe me, that changes everything. Now, to really get this, we need to talk about something called the OODA loop. It's a concept that has pretty much defined military tactics for decades. It stands for observe, orient, decide, and act. And the idea behind it is simple but incredibly powerful. Whichever side can race through this cycle faster than their opponent, well, they get inside their enemy's decision-making process and can totally seize control of the battle. So let's break down how AI just puts this whole thing on steroids. It acts like a supercharger for every single step. First, you've got Observe. AI-powered sensors and drones can watch huge areas 24/7, seeing way more than any human team possibly could. Then comes Orient. This is all about making sense of the chaos. AI takes all that data, fuses it together, and finds the critical patterns at machine speed. This leads to Decide, where the AI's analysis cuts down the cognitive load on commanders, letting them make faster, clearer decisions. And finally, you have Act, where automated systems allow for a much quicker, much more precise response. So you see, it's not just a faster loop, it's a way smarter one too. So what's the engine that's driving all of this? What's under the hood? Well, it's really a combination of three core technologies. Think of them as the three pillars that make up the AI sentry's brain. Pillar number one is all about giving machines the ability to see. But more importantly, it's about giving them the ability to understand what they're seeing with, frankly, superhuman accuracy. And the real magic behind this is a technology called convolutional neural networks, or CNNs. You can think of them as digital detectives. These things are trained on millions, literally millions of images to learn what a specific tank looks like, not just as a picture, but by recognizing its key features, pixel by pixel. So they can spot the unique curve of a T-90 turret or see the heat signature from an engine on a thermal camera, identifying threats faster and more accurately than any person could. But here's the thing: one pair of eyes is never enough, especially on a chaotic battlefield. And that brings us to our second pillar: combining all these different data streams into one single crystal clear picture. This whole process is called sensor fusion, and the best way to think about it is to think about your own senses. You use your eyes and your ears together to get a better sense of what's going on around you. Well, the military's AI does the exact same thing, but with a whole array of high-tech sensors. We're talking cameras, radar, LiDAR, thermal imaging. By fusing all that data, it overcomes the weakness of any single source. A camera might be fooled by smoke or darkness, but a thermal sensor isn't. So by combining them, the AI gets a much, much more reliable picture of reality. And the final pillar, our third one, is what brings all of this incredible processing power from some distant server farm right to the front line, exactly where it's needed most. This is tactical edge computing. I mean, think about it. In a firefight, you cannot afford the delay of sending data to a server miles away and then waiting for an answer. That's just not going to work. Edge computing solves this by putting the AI's brain, these small, really powerful computers, directly onto the vehicle, the drone, or even the soldier's gear. This means the analysis happens instantly. And just as important, it means the system still works even if enemy jamming takes your communications down. All right, so we've talked about the theory. Now let's look at how this is becoming a reality. Because this isn't science fiction, folks. This technology is being integrated into the U.S. Army's main ground platforms right now. First up, the legendary M1 Abrams tank. It's being totally reborn as the M1E3, what you could call a true cognitive tank. Its onboard AI is going to automatically identify threats, and, this is the really important part, rank them by how dangerous they are. Now, all that computing takes a ton of electricity, which is exactly why the M1E3 is getting a new hybrid electric engine. It's a perfect example of how one technology, AI, forces a whole cascade of other design changes, which could even lead to things like an unmanned turret and a smaller, safer crew. Next up, the Bradley fighting vehicle is becoming a proactive defender. It's getting upgraded with an active protection system, basically an AI-powered bubble that can detect and shoot down incoming missiles. It also has this amazing function called slew to queue. The instant the system detects the threat, it automatically swivels the main gunner's sight right to where it came from, turning defense into an instant chance to counterattack. But maybe the most revolutionary change is happening at the individual soldier level, with the Integrated Visual Augmentation System, or IVAS. This is essentially an augmented reality display built right into a soldier's helmet. Its AI can automatically highlight threats, it can stream live video from a drone, and it can show where all the friendly forces are, overlaying all this critical data directly onto the soldier's view of the world. It's incredible stuff. And the impact of this is it's profound. To quote one analysis, this gives the soldier unprecedented situational awareness. So it's not just some new gadget, it's a tool that networks each individual soldier into the entire battle like never ever before. You know, what's really fascinating about all this is that these military technologies, they're not being developed in some secret lab somewhere, totally isolated. They have direct parallels in our everyday civilian lives, and it's creating this powerful dual-use revolution. Just take a look at this. The same kind of AI that identifies threats for the military is also used in smart cities for public safety. The AI that assesses battlefield damage from a drone, well, that's used to analyze destruction after a hurricane or an earthquake. And the autonomous hazard detection in your self-driving car, that's a direct cousin of the autonomous threat recognition system in a tank. It's this amazing cycle where military tech and civilian tech are constantly pushing each other forward. But, and this is a big but, this massive reliance on AI creates a brand new and pretty insidious vulnerability. We've built this incredible digital sentry, but there's a ghost in the machine that we absolutely have to talk about. Every single system we've just discussed relies on one fundamental assumption, that the AI is seeing reality correctly. So, what happens if you can make the AI lie? And this is not hypothetical. This isn't science fiction. In one pretty famous experiment, researchers created this 3D printed turtle. Now, to you and me, it's obviously a turtle, but because of a very specific computer-generated texture they put on its shell, a top-of-the-line AI model consistently identified it with high confidence as a rifle. This reveals a just terrifying weakness. These things are called adversarial attacks. They are deliberately crafted inputs designed specifically to trick an AI into seeing something that isn't there, or maybe not seeing something that is there. Honestly, the best way to think about it is as the 21st century evolution of camouflage. But instead of hiding a tank from a human eye with a net, you might use a special pattern on a sticker to make that same tank completely invisible to an AI's digital eye. And that brings us to the most critical safeguard of all, the human-on-the-loop imperative. What this means is that while the AI can find and suggest a target, the ultimate, final decision to use lethal force cannot and should not be handed over to the machine. That decision has to remain fundamentally human. The commander's role isn't being replaced here. If anything, it's being elevated to that of the final ethical judge. So as we wrap this up, the ultimate takeaway is really this. As AI becomes completely universal on the battlefield, the decisive edge won't just come from having the smartest algorithm. The winner of future wars will be the side that builds the most effective, the most trusted, and the most resilient human-machine team. In the end, it's not just about the tech, it's about the partnership.